はい。はい。本日はご対応の中、
Everyone, thank you very much for joining our Robot Revolution and Industrial IoT International Symposium. My name is Nakatomi from Robot Revolution and Industrial IoT Initiative, RRI, and I will be serving as a moderator for today's session and panel discussion. This symposium is co-organized by RRI and the Ministry of Economy, Trade and Industry. We have invited industrial leaders in Germany, the United States, and Japan to talk about the paradigm shift in manufacturing business. We will have a global leaders dialogue today. We are in the midst of the fourth industrial revolution, and these revolutions will lead to various changes called paradigm shifts. What kind of paradigm shifts are going to happen? We need to anticipate that as we cultivate our future. And RRI, together with our stakeholders, formulated a list of 12 paradigm shifts and presented the list to the panelists. And I believe that the panelists will be making a presentation touching upon these paradigm shifts. We should keep in mind what kind of paradigm shifts could happen in the future as we go about this session. Today's symposium will go on for a long time, but I hope that you will stay until the end. Due to technical difficulties, we started later than the scheduled time. We apologize for the inconvenience. The session end time will be delayed by 15 minutes because of this delay in start time. And before we begin the session, we have one request. For the panel discussion, if you have any questions to the panelists, please use the question link on YouTube screen and enter your questions there. Now we invite the very first presenter, Professor Henning Kagermann. Professor is a chair of the Board of Trustees, former President acatech, and he will talk about COVID-19, a call to strategic agility. Professor is a former SAP chair, and he was also closely involved in creating Industry 4.0 concept, and he also joined us in the symposium last year. He is familiar with the developments in Japan. Now, Professor, the floor is yours.
Thank you, Nakatomi-san. Ladies and gentlemen, there's a common saying, in every crisis there's an opportunity, and we can ask ourselves if this applies to the current crisis as well, and I believe the answer is still pending. But what we can do is that we can look back and ask ourselves if we have taken the right forward-looking actions during the crises we have seen during the last 20 years. So if we go to the next slide, please. The next slide, please, and we can see that in 2000 we saw the burst of the dot-com bubble, more or less originated directly out of the ICT sector. What we learned was that the preaching to rip and replace old technology by the future one, which at that time was believed is completely internet-based, is not working. Businesses need manageable transformations and have to secure the investments of the past. On the other side, what was completely underrated was the potential of electronic marketplaces, as we can see it if we click to the icon and to the icon, yes, and see that as an example, Amazon, many managers had misjudged the potential of exponential growth. So you see it happens very slowly. Nothing happens for many years. So many decision makers just step out of these opportunities, but suddenly it takes off rapidly and leaves part of the potential competitors behind. So if we move back, please, back, and go to the next crisis in 2010, that was the financial crisis. Coming out of the banking sector, the first response from regulators was to make sure that they strengthen the risk management, in particular in banks, in order to avoid another bailout from the public of, let's say, bankings in trouble. A first attempt to a resilience cycle was made, but all of this was done for the banking sector only. On the other side, I think what worked well is that we, in particular, I myself was such under the impression of the suddenness and intensity of the crisis that we thought, can we not implement more adaptable businesses and strategic agility in order to help companies to absorb shocks of that strength more easily? And that was the beginning of the concept Industry 4.0. And if we click please to the icon to the right-hand side, I just want to recall that we combined new aspects like the aspect of digital twins for all objects, of leveraging the potential of the Internet of Things, of entering more into the advantages of autonomous systems, leveraging the progress that was made for sensor technology, for artificial intelligence, in particular deep learning, and the shift from traditional robots to more collaborative robots which left the cages and worked directly with people, combining these with some of the ideas that came out from the 2000 crisis, mainly the idea that the business model of the future is services based, everything as a service, that there will be a kind of platform economy which helps us to utilize resources better and leads us to what we call now a shared economy. And if we go to the business to the consumer market, which was called the attention economy. If we go back, please, then we see that in today's crisis, there are different approaches underway. And if we click to the icon on the right-hand side, please, we see some of them. In particular, in Germany, it's obvious that we have to accelerate the digital transformation. Yes, we focus on the health sector where we have seen that our information base isn't good enough, so we have to speed up in building health databases. We have again to remind our government that a few years ago, we asked for viewing the upcoming biological transformation as the next big thing, which would have helped us today might be to be faster in the development of the urgently needed vaccines and drugs. On the other side, there is a clear focus on everyday life because we see the shortages we have in our digital infrastructure, and we have to come up with new ideas how we cope with the challenges of social distancing, in particular in schools and in the way of remote working. Finally, the concept of digital twin will be even more important because it helps to support remote working. We will continue to deliver on our promises of sustainability with driving towards the circular economy, and we have to rethink the way of working more deeply. If we go back, please, then we can say already today, there will be a next crisis, but it will definitely not be a pandemic. So that means we have to prepare for a crisis, and we have to prepare for resilience of each type of crises. Please, if you go to slide 6, please. Then we see this resilience cycle, which tells us that resilience is more than just recovery. It's recovery and rethinking and reshaping the future in a way that we achieve finally an improved reality. And with increasing uncertainty, it means we have to do scenario planning with several dimensions in mind. That starts with the geopolitical question: will there be trade wars? Will there be stable value chains in the future? Will the economic outlook be U-shape? Who knows? What about the technological progress, the social environment? Will consumer preferences be changed forever or just for a short time? And what about the impact of the regulatory responses? Will the billions of dollars we have spent really have the impact we anticipate? If we go to the next slide, please. If we go to the next slide, please. We come back to the vision of Industry 4.0, and when we were looking to the ideas of potential paradigm shifts as they were brought up by the Robot Revolution initiatives, we ask ourselves, are some of them not already addressed by Industry 4.0 and smart services? For example, the business model of the digital age, we believe, are smart services. Yes, we have done our homework to come to more adaptable operations. And yes, we believe that there is a clear shift from enterprise to open ecosystems and interoperability, in particular on the semantic level, so that machines can understand each other's based on international standards, is something we are driving together with our friends from different countries since many years. On the other side, I have to agree that in particular the topic of education, lifelong learning, on the job with smaller so-called nano degrees is still, let's say, in discussion but not implemented. I mentioned the importance of resilience and really going and making steps towards a circular economy. And finally, I also believe that we have to rethink the way we are building our businesses, and we have to look to a business more as a set of portfolios where it's easy, let's say, to get rid of some parts of the business and adding newer parts of business in a seamless and quick way. So if you look to the next slide, please, then you see the vision of Industry 4.0 as it was re-articulated last year, and we had in mind to present these at the Hanover Fair. You see the topic shaping digital ecosystems globally will not change. I think that is the right way to go. We have again stressed the importance of interoperability and sustainability, but there was an add-on which we called autonomy, which means, I would say, more self-determination. It's not about self-sufficiency, it's about self-determination. And if from today's point of view, I would add something, I would add the concept of resilience. So now let me go deeper into these three topics. And please, on the next slide, we see what about autonomy. So there are lots of topics in the area of security, about e-identity management or security by design, in technology development, where we still will go for order-controlled production and value-based services. That will not change. If you go to the digital infrastructure, yes, the concept of distributed computing is exactly the right one. We will continue to focus on that. But there is a new one which we just highlighted at the end of last year, which we called Gaia X, which gets a lot of new importance, and I will come to it. In a nutshell, if I would summarize, I would say it's about the freedom to select the technology of choice and the business partner of choice. It's about the freedom to switch to another ecosystem partners seamlessly. It's about data protection and security. On the next slide, you see that Gaia X is more or less a European project. It was initiated from the platform Industrie 4.0. We then combined forces with France. In the meantime, there are many more European member states that want to join the initiative. An organizational body is set up. And if we dig a little bit deeper in the technology, then we can see on the next slide, please. On the next slide, we can see that's all about a framework for open collaboration. And it's addressing the level of infrastructure, which means the level of cloud and edge computing. And it's addressing the level of data, spaces, and platforms, which is the level of platform as a service and software as a service. The idea is to have federated services and data managed by some generic central services like identity trust, a catalog, and a trustworthy data exchange. And finally, to apply a set of rules which govern the relationship amongst the members of this ecosystem. That guarantees the kind of compliance we want. It guarantees portability of data and interoperability of services. It guarantees data protection in the data spaces and helps others, let's say, to build on this infrastructure to develop smart services and new business models of the digital age. If we go to the next slide, please, then we see the topic of interoperability. Nothing new. I think the asset administration shell to define digital twins are getting even more important. We have defined several levels of autonomy. Once artificial intelligence is entering the area of Industry 4.0 more heavily. But if you look to the regulatory framework, I have highlighted the topic value by design, which means that we have from the beginning to implement certain cultural and legal values into the system, in particular because of the intense use of artificial intelligence. So the idea here is we want to avoid a single point of failure. We want portability, and we want an infrastructure which allows us to build these composable businesses, and that deeply requires international cooperation. The next slide comes to the topic of sustainability. And here the difficulty now is because of the crisis that we find the right balance between the economic, ecological, and sustainability requirements. Yes, lifelong learning is important if you look to social innovation. Yes, circular economy and looking to the entire product cycle is important if you look to environment. And if you look to economy, agility is key. But what's new is social distancing. And in the background of social distancing, the question of what are the new styles of working. And if we go to the next slide, then I tried to combine the discussions we had at the last symposium here based on a joint Japanese-German initiative where we were looking into the future of collaboration between hybrid teams of humans and machines and ask ourselves, what can we do to come to a beneficial symbiosis between human and machine in order to look to the different tasks of business processes and to make up our mind where it's more human only, like if it comes to creativity or judgment of certain outcomes, where is a machine better? if it comes to transaction or prediction, and where can humans complement machines in terms of training, and where can machines complement humans. On the other side, now it's about the question of on-site and remote. So our question will be, what kind of services are preferred done on-site, like assembly production? What can more easily be remotely, and which type of services are hybrid? We have to do both, like, for example, design or maintenance or whatever. So that's one part. And if we go to the next slide, please, then I just want to highlight the idea of circular economy. I think all of what we have done in the past pays into this idea, because it's about a complete rethinking of the entire life cycle of the product, starting from reuse of recycled raw material, having a design which supports remanufacturing, having a usage which is more based on as a service instead of, let's say, using an individual product, etc. So we have now a circular economy initiative in Germany going on for a few years, and looking forward that that works. Let me come to my last slide. Here again, I want to remind us that resilience is also rethinking, reshaping. In terms of technology, my personal point of view is that we will need faster progress in developing medical ingredients as well as new functional materials. As a physicist, I have a strong belief that we have to, let's say, make use of the quantum technologies of the second generation, and we should push the development of quantum sensors on computers even faster than we have done it might be in the past. In terms of application, I'm not looking so much to something new in IT. We should more focus on what we have and make it available to everybody, improve our digital everyday life, and see that we can bring the collaboration between autonomous systems and humans more closer, because that will help us if we come to society, let's say, to free up creativity and make the work for people better in the future. So for application, my topic is resilience. And if we come to society, I would say the topic of digital sovereignty and value of design. We have to cope with the aging society and sustainable growth, and decouple future growth from, I think, the consumption of resources, which is the highlight of circular economy. All of that requires global collaboration. And let me just finish in saying that if we want to come to an improved reality, it definitely means that on a national level, we have to manage these disruptive transformations by smartly balancing out the three dimensions of sustainability. We have to look to the social impact as well as to the economic and ecological ones. So we have to build partnerships amongst all stakeholders. We have to base our decisions on available evidence and build trust and credibility. And international-wide, I think we should continue to share knowledge as we do it today. We should share best practices, and we should respond, and we should have respect that countries have different cultures, they have different ways in order to tackle solutions, and we should just respect each other's approach to these kind of solution finding. Thank you very much.
Professor Kagermann, thank you very much for a very insightful presentation. It was not just about COVID-19, but you also talked about potential crises that we might face in the future. Now we have the second speaker from the United States, Professor Mark Johnson from Clemson University. Professor will be making a presentation titled Lessons from the Team of Rivals Approach to Industry Innovation in the US. Professor has been involved closely in the advanced manufacturing strategy creation, and he also supported our visit to the United States in February this year. Professor, the floor is yours. Professor, can you unmute your microphone?
Thank you. It's my apology. Hope much better? Okay, good. So my name is Mark Johnson. I'm a professor at Clemson University in the United States. And as noted, first of all, thank you for inviting me here to speak with you today and to spend some time together. And it was our pleasure and honor to host a group from the Robot Revolution Initiative and Industrie 4.0 for part of a visit to the United States earlier this year before COVID. It has been a very, very long year, I think, for everybody, but reflecting back at a number of the issues that we all discussed at that time. And preparing for this talk, first of all, my colleague Douglas Ramsey helped prepare this as we were talking together about that visit for the Robot Revolution Initiative. And one question that we were asked over and over again, and not just on that visit, but many times with both in the United States and elsewhere, is in the United States, advanced manufacturing, similar to Industry 4.0 or the Robot Revolution Initiative, for the government of the United States, who's in charge of your initiative in the United States? And this is a common question we get asked. And it's more broadly a question about who's in charge of industrial policy for the United States. So today I thought what I would talk a little bit about is start with how does the United States get where it is? What I will propose is that we actually have what I would call a team of rivals approach to industrial policy. This is not new. This has gone on for the entire history of the United States, of having an industrial policy that is around a team of rivals approach. And it really reflects many of the historical events we've had across the United States. So just to give you a starting point, that this is a question that gets asked often, even within the United States. I found an article from the Harvard Business School just about 40 years ago by a professor at the time, Robert Reich at Berkeley University. The article was a coherent industrial policy is a practical necessity for the United States. Robert Reich in 1982 was a professor. 10 years later, he became a government official in charge of the United States Labor Department. We had him become the head of our Labor Department, but we did not embrace an overall industrial policy as a central industrial policy at the time. However, if you look at the history on the lower left, there's an image of the size of the economies around the world. In 1980, the largest economy was the United States. The Soviet Union was the second largest, and then Japan, Germany, France, and the United Kingdom. We roll that forward to 2019, and clearly we've had a number of geopolitical shifts in the time since then. But economically, the United States, Japan, and Germany are all still number 1, number 3, and number 4 in terms of the size of the economies. So, you know, not having an industrial policy, the United States is still moving forward, clearly doing well at what it winds up doing and has continued to grow. However, this call for it's a time for America to embrace an industrial policy continues to today. Jared Bernstein is an economist who worked in the Obama administration and works at universities and think tanks today. This is not a new question even in the United States. We actually have an industrial policy, is my point here. And that industrial policy is this team of rivals policy. So if we go back to our history about industrial policy in the United States, the United States was actually formed at a very interesting time that's just a matter of good luck, good fortune. The timing in 1776, 1775, the beginning of our independence, coincided with the beginning of the Industrial Revolution. In fact, in May of 1775 is when Watt and Malden filed their first patent and started their first company together to make steam engines. So those two things wound up happening at the same time, and the United States was a new country that was a place where that could be deployed or developed. One of our founding fathers and our first Treasury Secretary, Alexander Hamilton, actually looked into manufacturing, and he wrote a report for our very first Congress. And I've actually looked at this physical report itself. You can go to our Library of Congress and find that report still. And it says that it's not only wealth, but independence and security of a country appear to be materially connected to the prosperity of manufacturing. What this led to in Alexander Hamilton is widely recognized as the person that established the foundation of the free enterprise system for the United States and really built that value strongly. Another 70 years later, Abraham Lincoln, president during the American Civil War, in the heart of that turbulent time, actually started a very important program as well, something called our land grant university systems. This is a university a public university in every one of our states dedicated to science and engineering, science, agriculture, and engineering, hence the land grant university term. And so, the federal government was very involved in establishing our educational priorities. And the quote from that is, it's on behalf of the people who have invested in these public universities, their hopes, their support, and their confidence. And then a third issue that wound up coming up about 80 years later, in the middle of the 20th century, Vannevar Bush, who was the president of MIT at the time, he was also the first what we would call science advisor to the President of the United States, was looking at how science and technology in the middle of the 20th century might best be used for public good in the United States. And he wrote a very influential report called The Endless Frontier. And a quote from that is, it's that the economy should be founded on new principles and new conceptions, which in turn are painstakingly developed by research in the purest realms of science. From this, we wound up developing our National Science Foundation directly from that. Our National Institute of Health wound up coming out of this directly. And really that focus on using technology to drive economic growth. So we have those three principles of free enterprise, education, and technology that really become the foundation of our industrial policy. So where does this get used? And there are really what I would call 4 real realms or areas at which we wind up having these teams of rivals. And in the United States, people think of the United States government as being that federal government in Washington, D.C. But in fact, every one of the states in the United States has its own government, as well as the federal government. And so we have this, both the interest of the states and the federal government that's being balanced on those two. Even in Washington, D.C., within the federal government, we have what are called co-equal branches. These are the different parts of our federal government, and they both have an interest in industrial policy. And then within the executive branch, that is what the President of the United States oversees, we have different departments or agencies, and each one of those may have an interest in manufacturing and have policies they're trying to carry out. Those are all in the public sphere, and then in the private sphere, we have universities, corporations, and research labs that all have an interest in manufacturing and have an important role in this use of free enterprise, education, and technology that drives industrial growth in the United States. So I'm going to talk about each of those four and then compare that a little bit with the RRI 11 RRI Robot Revolution Initiative principles with the US advanced manufacturing approaches, and just have that as a bit of a comparison between the two. So within the state level governments, we have 50 states. These are sometimes referred to as experiments in democracy because they all have their own responsibilities. They're actually organized by themselves. And then we, as well as, and simultaneously with the federal government. And in fact, they have resources that wind up being used for manufacturing. If you look at the revenues, that is the public sector revenues, that is the money that comes from taxes for sales and properties and income taxes, about, depending on which state you're in, anywhere between 15 and 35% of all governmental revenues, money, comes through the state level. So it's actually a substantial amount of resource. Often it's used for combination of the foundation money that winds up supporting our public universities. These are our 4-year science, technology, engineering, and mathematics, referred to as STEM universities. These become the foundation for the engineers and the scientists and the managers that wind up leading our future industrial ecosystem, our sector. We have what are called 2-year technical colleges or community colleges. And the states wind up providing most of the support for those colleges. And these are the community colleges that wind up providing 2 years of training after high school for many of the people that become the workers in the factories and in the industrial environments. And often the people that wind up in leadership roles, sort of in the managing the day-to-day work in the industrial sector. So that support comes from the state level. So how they wind up spending that becomes really important to how the manufacturing works in that area. Much of the support for our public schools in the principal education, so kindergarten through 12th grade for the children, comes from state and local money. Also relevant, though, to manufacturing is our state and local governments have the ability to issue bonds. So for if manufacturers wind up coming in there, there's fierce competition between states for getting a large manufacturer to locate where they are. Where I live in South Carolina, for instance, BMW has a very, very large factory. It's actually their largest factory in the world, located about 15 miles from where I am here. So I will point out 70% of the product that comes out of that factory is sold internationally. It's exported out of the United States. So this means the United States has to compete on an international basis. But within the United States, again, that 50 states each competing with each other, companies and people over time wind up moving between those. And there's a competition to wind up having that economic growth. Then within our federal government, the US budget, one might hear occasionally the president is proposing to do one thing or another, either increase or decrease parts of the federal budget. But the federal budget, the annual budget of the United States, does not come from the president. It comes from Congress. The president proposes the ideas. Congress is who creates those budgets. So these are called co-equal branches. The other side of that, the tax rates, again, proposed by the president, but the laws are actually passed by our Congress. And so periodically those wind up getting adjusted. Both of those clearly have impact on industrial policy. And in fact, we can wind up having conflict at times between these policies, even when there is political alignment between our Congress and our White House. So for instance, since 2018, 19, and 20, the president, the executive branch, has proposed canceling, that is, zeroing out the funding for Manufacturing USA institutes. These are public-private partnerships dedicated to US industrial development. Congress from 2018 to 2020 has actually increased the funding on those. So you may occasionally hear that the US is reducing something, but it's Congress that actually decides how much money is going to get spent. And then within Congress, there are different policies and plans, even between the different parts of the Congress that are responsible for energy and commerce versus science and technology. And of course, these things always have competing interests because our US Congress is elected only every 2 years. It's elected by states and districts directly. So it's the closest thing at the federal level to what the individuals in the different places are like, right? So there's competition between these things, even at the federal level. Then within the executive branch or the executive agencies, this is the part of the US government that the president oversees. This is a picture of our US cabinet. This is the heads of all of those agencies. And as one might imagine, each one of those heads of an agency has responsibility for that agency, and that agency may have manufacturing issues they're working on. So all of them feel that they are all responsible for manufacturing. And so they have interlocking missions. Often that mission is trying to serve a different end. So we have Commerce, Defense, Treasury, Energy, National Science Foundation, a number of places between these. So I'll try and speed up here a little bit. And then in the private sector firms are closest to the market, where our universities are our pipeline of talent, and our national laboratories are our science and technology powerhouses that underlie that. What we've tried to do in the past few years is to establish these, what we would call public-private partnerships, where bringing together those parts of both of those so that they can work together to get the best connection to manufacturing. So you have the Smart Manufacturing Innovation Initiative that is part of Manufacturing USA, that is probably the close Innovation Institute, that is probably the closest thing to the Robot Revolution Initiative or Industry 4.0, Plattform Industry 4.0 in the United States. So with those principles, what in reality is no individual organization is actually in control of US industrial policy. One overriding principle in trying to establishing the federal involvement or the public sector involvement is there's an avoidance always of trying to pick the winners and losers on the public sector side and let that be solved through competition in the private sector side. Because the idea is that the best approaches wind up rising and surviving. So for instance, in the National Science Foundation, things like our engineering research centers have been very successful, where there have been programs such as the Advanced Technology Partnership, or in energy, the industries of the future, that have not wound up continuing on. So how do we wind up building these public-private partnerships for that long-term growth that can wind up leading to success? I think it's well recognized in the US, there is a tolerance of individual failure that's wind up becoming success, leads towards success. So I always like the quote by Winston Churchill that says, Americans always do the right thing only after they've tried everything else. And I think this is consistent with how our industrial policy winds up working. Comparing very, very quickly here with the US structure, we have the 11 organizing principles of the Robot Revolution Initiative. I would say the US underlying metric that winds up, or theme that drives our economic growth is our industrial policy, is economic growth and job creation. Those two things are the highest underlying values, political values, that wind up supporting the efforts that people wind up driving towards those industrial policies, with the idea that we try a number of approaches, and the ones that become the most successful ultimately wind up rising to the top on that. I think personally, there's opportunity for this global cooperation even between what's going on in Japan, what's going on in Germany, what's going on in the US. There are plenty of examples. MP3 is a great example where there was research in the United States, there was invention in the UK, there was standardization that happened in Germany, there's manufacturing that wound up happening in Japan and in Asia, and then there are services that wound up coming back in the United States. Can we, for instance, do similar sort of alignment around things like the asset administration shell that Professor Kagermann was speaking about just before this? And finally, this is because we all have these shared goals that we have. For instance, the UN sustainability goals are well aligned with the outcomes we want to wind up getting to, because if we wind up having these efforts together, we wind up promoting prosperity and growth in our economies and sustainability in our environments. We wind up not duplicating the work, but we learn from each other. That leads to stability and safety as well as quality of life. So with that, I think we can wind up moving on. Thank you very much.
Thank you very much, Professor Johnson. And thank you very much for keeping the time in making your presentation. On teams of rivals, historic, geopolitical, as well as other aspects, you have provided your explanation, and it was really interesting. The public-private sector relationship, the relationship between the government or administration as well as the Congress, it's quite different from Japan. And also, finally, you talked about the importance of international collaboration, NPEG 3, asset administration, shell. You have also mentioned that, and it was truly interesting. So once again, thank you very much, Professor Johnson.
Thank you. I'm sorry I had to speed up at the end.
Well, yes, thank you very much. Maybe later on during the Q&A, you can add more comments. Well, then, thank you very much. Moving on, we have Professor Seiko Shirasaka. He will be talking about designing social and industrial structures from a holistic perspective, social and industrial architecture design in the digital age. Professor Shirasaka is from the Graduate School of System Design and Management of Keio University. Professor Shirasaka has been involved in the Digital Design Center, and so we now would like to ask him for his presentation. Thank you very much for the introduction. I am Shirasaka from Keio University. Thank you for giving me this opportunity to speak. Dr. Kagermann, and then we had Dr. Johnson, and now I'm speaking. It makes me nervous to speak after these two prominent people. But I will be speaking for about 20 minutes to talk about the basic thinking behind this title here. Now I'd like to share the slides as I speak. So as was introduced, I will be looking at designing social and industrial structures from a holistic perspective. So how do we design social and industrial architecture in this digital age? So the first thing I'd like to share with you is from Harvard Medical School. This was based on an experiment done there. There were 5 X-ray photos, and these were shown to radiologists, asking them to find cancer cells. And then actually, this is the 5th one. Up until the 4th one, radiologists were able to identify where the cancer was growing. But on this 5th slide, many thought that there was nothing wrong with this. However, you may already notice, but on the right-hand top side, there is a big gorilla in the picture, much bigger than actually cancer. But 83% of radiologists missed the gorilla in the photograph. And this experiment, eye tracking cameras were used to see where the radiologists were watching. Actually, they have seen or brushed or their eyes did look at the gorilla. However, it seems that people subconsciously select information. So they are not able to process all information that they take. So they have to select which ones they will process inside their minds. So that is called the cognitive bias. People have a bias based on cognition. And if you repeat certain things, then this bias sticks with you. For example, in this example, the radiologist, they are only looking for cancer cells when they look at x-rays. So even if the x-rays are showing something different, they are still looking for cancer. So that's an expert bias. And I will be talking about something more holistic, not just looking at the bias itself, but you have to look at something more whole. But this expert bias gets in the way because everybody is an expert of some certain field. So then what should we do? It's all about diversity. Experts should try to have a perspective or try to have a different bias than the one that you have and try to combine your bias and your expert perspective with others. It's easy to say, but difficult to do. And so we want to provide a tool to be able to do that, a methodology to do that, so that we can have a more holistic view. This is my self-introduction. For 15 years, I have been working at Mitsubishi Electric, involved in the development of satellites. I had been involved in large, complex systems. I have been at Airbus for about 2 years as well, and I was able to learn there. And then after coming back to Japan, I went to Keio University. I started to teach system engineering, and then I moved on to Keio University to teach. And while I do that, I am in the Digital Architecture Design Center, and I am a chair for that. And so we are trying to work in an interdisciplinary manner, going across different sections. Well then, why is it that we need to have this holistic perspective? So system thinking is what we call this holistic perspective. There are two aspects. We need to see the whole system thinking, and also we need to see the interrelationships. That's the systematic part. So it has to be systemic as well as systematic. So systemic part, looking at the whole, and this is actually very difficult. It's easy to say, but it's actually difficult to do. So how do we do this? This is the hint. You have the time axis from the start to the end. You have to look at the time, not just one point in time, but the flow in time. You need to have a spatial axis, not just where you are, but you have to look around you. You have to look at the whole space. And also the semantic axis. And this is difficult to do, but why is it you're trying to do this? What are you trying to do? And how are you trying to do this? You have to look at this. So you need these three axes in order to have a holistic perspective. So that's what you need. Well then, I'd like to look at 3 reasons. These are not all, but I chose 3 reasons on why is it that we need to look at things more holistically. Starting from the bottom here, this is saying that the people's values are changing. What we cherish, what we see as value is changing from the past. The top one. And also the systems that we can provide is changing. Even the services that we provide are changing. And then the last one, combining the two, we see that rapid changes are occurring right in front of our eyes. So these three reasons are why we need to think as we have a more holistic view. Now, the things we provide are changing, and in the background there are a lot of things, but I like to point out two things. System of systems is one thing. You had separate systems that are now being connected together, and the second one is digital. Cyber and physical is now becoming one and together. So these are the two big things. So system of systems, I think you all know, but INCOSE has issued a systems engineering handbook. I've taken this from that. So let's say you have Canon EOS cameras on the left-hand side, and on the right-hand side you have HP printers. Canon EOS cameras are used to take photographs, and then the HP printers can print them out. Well, then the Canon cameras taking photographs and printing in HP printers. If you combine these two, it means that you are looking at not a traditional system, but a new type of system, which is a system of systems. So if something goes wrong, who are you going to complain? So from end to end, nobody is actually saying that this is going to work if you connect the camera with the printer. But that's the characteristic of system of systems. And of course, for this to work, you need to have a standardized interface to make products. But now we are connecting things that people have never thought about connecting before. Mark Mayer in 98 came up with the architecting principles of systems at the top. So you had independent things working independently, but they will be connected where, when, and where you need them. And also the management is independent. Cameras are managed as cameras, printers are managed as printers. It's not as if you are not buying the two at the same time and they break down at the same time, that they need updates at the same time. You have to do them individually. And so things are developing evolutionarily. So that's the big characteristic of system of systems. Well, then, where do we see such system of systems? The smart grid, smart services, IoT is also one of a system of systems. So from end to end, nobody is managing it, but things are simply becoming connected together. And we are now able to provide such services. Well, then what happens? Things that have never been connected before are now being connected together. If we have connected before, we know how they may work, but now we are connecting the unthinkable, meaning that we will see new stakeholders becoming a part of the system. Or maybe we will lose somebody who was connected, or something will be added along the way. Something that was unscheduled may happen while you are operating. So in the past, systems were designed and then they were provided, but now we can't really do that. As you operate, the system will change as you operate. Which means that we need to really look at the time axis. Things are changing as time goes on. Space also. You have to look at different spaces that will be connected together. You can't just look at one point. You can't just look at the initial design. Even while you operate, things are changing and you have to look at that. Things that have been connected may no longer be connected, and you may be adding new connections. And then you have to add this digital aspect. Digital means not just replacing what you had with IT and technology. It may be doing the same thing, but it's doing it in a totally different way. And the reason for doing it may change, and how you do that may change as well. So you have to look at everything, or else the system providers will not be able to think, we will not be able to operate, we will not be able to manage. Now, the second point about the changes in the environment. This is the World Uncertainty Index. You can see that it's suddenly going up, but things are rapidly changing. And in systems of systems, we are connecting independent systems together. So individually, the system will only affect itself, but now that they are connected, the impact could be felt in a separate system that is connected. So the changes that we feel at one point will be affecting others. So the environment changes is rapid, but we are also seeing that the impact of a certain change will spread very quickly. So the US DoD has used this word VUCA, volatility, uncertainty, complexity, and ambiguity. So we are no longer standing still. We shouldn't think that everything is the same. Our surrounding is changing. Don't think that you understand everything because your surrounding is changing. You may not really know what you thought you know. Now, the system thinking. What is it that we need to think? As I said earlier, you have to look at the whole and then you have to look at the interrelationship. Now you have to look at the interrelationship with the outside world, as well as the interrelationship inside the system because technology is advancing. And you have to look at it from the spatial, time, and semantic axes. This has to be done again and again and again, repeatedly. The third point is the system characteristics. Now, in system engineering, we have this word ilities. What is this? Availability, reliability, or maintainability. So you have these words that end with ility. Specialty engineering is the word that was used in the past. But nowadays it's called ilities. So what is this? It's about properties that can only be captured when you look at the system itself. You can't understand security if you look at just one part of the system. Reliability, you won't be able to understand unless you look at the whole system. You have to look at the whole system to understand these ilities. And this is from an MIT paper. The ilities, the number of ilities are increasing exponentially as the years go by. From the past, you had things like quality or safety, but now we have adaptability. Interoperability is another one, or sustainability. Professor Johnson mentioned this, but we have these new ilities coming up. Now, this vertical axis is a number of paper, but you have this on log scale. So actually, it's really jumping up and spreading. And we have to think about all these things. We are now living in such an era. Also, we are now responsible for proving these system characteristics, safety, or RAMs in railway. So safety, reliability, maintainability, all these four aspects will have to be proved now. Well then, how do we react to this? Somebody has to think about the total system architecture, and that's where this thinking comes in. So system architecture. So system thinking turned into systems approach. Now you need a goal-oriented approach. So goal orientation, as you look at the whole thing and also the interrelationship. And when we try to do that, since we have these biases, we need to have diverse people we have to integrate these diverse people so that we can see the whole from multiple perspectives, and that's the system architecture. The system architecture has to be described from different perspectives. Well, then, what is the definition of architecture? It's a fundamental concept, it's a property of systems. You have the elements and the relationships express that architecture, and also it's the principle of the design and evolution. So elements and relationships, as well as the principles, must make up the characteristic of the architecture. I've already talked about this slide, so moving on. So then how do we do this? That's the difficult part. System architecture or system architects. Architect and engineering, what is the difference? Mark Mayer said in his book, and this is actually taken from his book, but this part, engineering is about science and art. You have science and art. Architecting is art and science. Art comes first. So science is where you have reproducibility. Art is something reliant on people. What is the difference? Science is about analysis, and so you have to look at the equations. That's why you can reproduce something. But in art, it's heuristic. It's based on people's experience. So it's not just the processes and the rules that you need to set. You need to develop human resources in order to have architecting. And we have been trying to develop human resources, but that has been very difficult. And the reason is because you have to handle a very high level of abstraction. But you also have to do something very concrete. You need to understand the theory, but you also need to understand the practice. And you have to apply it not just in your own field, but you have to apply it to other fields as well. Also, as I said, we have to bring together and integrate the specialists, meaning in order to integrate these specialists, you have to understand that and you have to show the result of that integration. And that skill also is very important. But this is very hard to acquire, and that's why we have this Digital Architecture Design Center within IPA. And this is where we are trying to look at new industrial architecture, not just the hardware and software, but looking at the rules and standards as well, as we look at the whole thing and try to realize that as an architecture. And we are also trying to nurture new human resources who can do that. And we have a lot of people coming, but we want to have more people coming in. So, three main things here. So, having a holistic perspective. And that's because the values are changing, the ilities are changing, what we provide are changing, the system of systems, DX, IoT, very rapid changes are occurring. And because of that, we need to have this system architecture approach so that we can look at the whole thing, not just the hardware and software, but also the whole system. But this is not an easy thing to do. But still, we can't stop. We have to cooperate with the whole world in order to make this possible. So with that, I would like to end. I just rushed through, but thank you very much. Thank you.
Professor, thank you very much. And thank you very much for cooperating with us on time management. We have to address the temporal, spatial, and semantic axis, and also have to think about the increase of ilities. It's very difficult, but it's a very important task that we need to tackle. So based on the presentations that we heard from three speakers, we would now like to move on to the panel discussion. Let me introduce the panelists again. Dr. Kagermann, Dr. Johnson, and Dr. Shirasaka, and I will be serving as a moderator. We are behind the schedule by 15 minutes or so, but we would like to end the session by 9:15 p.m. Japan time. First question to all three panelists. I have a question to each of you. The framework of the industry. My first question is about how to popularize such industrial frameworks. Dr. Kagermann, if you could start. In Europe, as you explained, Gaia X effort is undertaken, and also there are developments surrounding the data zone in Europe. And you also touched upon the autonomy. What do you think are the challenges in designing such framework and popularizing such framework? People in Japan are focusing their attention on the development there, especially when it comes to Industry 4.0, the free flow of data and interoperability. When it comes to that, how are European countries trying to create the connection between EU countries and non-EU countries? We need to maintain the security and autonomy, but how are you going to balance that and the achievement of interoperability? So this is the question to Dr. Kagermann, and the next question is directed to Dr. Johnson. RRI, as I mentioned earlier, sent the delegation to the United States in February, and we saw a sample of advanced manufacturing activities. And in the United States, as we heard from Dr., fierce competition is the basis of promoting advanced manufacturing using various and multiple public-private partnerships. Such partnerships are quite active these days. So how can you expand the collaboration, and in which area can we expand collaboration as we also base our activities on competition? In Japan, when it comes to the expansion of collaboration and competition among countries, they are conflicting concepts. So, and the next question is to Professor Shirasaka. In Industry 4.0 and Society 5.0, system thinking and system engineering needs to take root. You said that in your presentation. So in order for them to take root in Japan, what is particularly important and necessary? So these are the questions to the three panelists. First, Dr. Kagermann, can you start?
Yeah, thank you. We have to look back. If we promoted Industry 4.0, there was a huge concern, in particular from the medium-sized enterprises, that they had to share data because it's all about ecosystems. It's about sharing data and information. And if you are a small enterprise, you are concerned that you cannot, while you share data, protect your intellectual property. That's the biggest concern. And that is something we tried to address with Gaia X. So it's about a framework for collaboration, but it's about a framework which allows seamless data flow and in parallel protecting the integrity and the intellectual property of the data. So therefore, we address the concerns of the medium-sized enterprises, but in parallel allow the, I would say, global cooperation. So now it's based on the principle of public, globally accepted standards. That is important. But there is a second point, and the second point are European values. That's the second point. So everybody, every provider can participate, be it from Japan, US, China, whoever, but he has to respect the European values, which are not so difficult, I would say, and very close to the Japanese ones. But that is the concept of autonomy and self-determination. Don't get me right, that is not self-sufficiency. It's just to say, okay, we have certain values in Europe, we agreed upon them, everybody knows. If he wants to make business in Europe, he has to stick to European values. It's like localizing certain things, legal values, etc. That's what about. So what are the challenges? The challenges is that we have now to come from design to implementation. This is much easier if you start in one country like Germany, or with two countries like France and Germany now. But now it's spread across Europe. And you know, Europe is more diverse than the states in the US. So it's more difficult to come to a joint agreement. And therefore, I think to implement now fast the common services, and I would say to agree on the governance of this entity, that is the next challenge. And on the other side, we would appreciate, let's say, these, if Japanese companies in particular would join the initiative, that would be helpful for us as well.
Very good. Do you want me to just go directly as a follow-up?
Yes, go ahead, please.
Okay, thank you very much. So as I understand your question, to make it a simplified question on that, how do we get direct competitors to work together in areas where we all move together faster in a way that's effective, instead of where competition naturally winds up every individual firm naturally wants to compete head to head, and that seems a bit in opposition to the idea of how do we wind up finding shared collaboration. So how do we wind up accomplishing that, and what are some of the things we can do? I think if you look at a couple of different sort of short range and long range solutions, we need to do both of those, because these are problems that we need to solve now. And we also have to make sure that we're establishing the foundation so it's solved for the future. In the short range, I think if you look at both the Industry 4.0, Robot Revolution Initiative, and something like the US Smart Manufacturing Institute, Manufacturing USA Institute, the industrial partners of all three of those groups, many of those companies are the same companies, because these companies have worldwide footprint. So there is a shared interest for them to have RRI, Industry 4.0, and the US all talking to each other, because if nothing else, it makes their engineering challenge simpler. If, for instance, we had 3 different standards, they would literally have 3 times as much cost to accomplish their goals, which is to make a product that they can deliver. So one way is, in the short run, how do you appeal to the inherent competitive powers and say, how do they become more competitive by working together? In doing that, one thing that things like this meeting can wind up doing, and in the US, for instance, we call this the power of convening on the public sector. And that is to say, the government can call a meeting together where all of these companies can, in the public and highly visible manner, talk to each other. Where if they were to talk to each other behind closed doors, that would have problems. But coming together in an open forum to discuss the issues that they have and find those areas where their common interests are aligned, and then work on those issues together. But the first thing is bringing those groups of people together to find out their common interests. It may just be that and I believe all 3 of us are professors as part of our life. As a common issue, this is the longer term. is making sure that as these ideas are developed, we're not only implementing them in industry, but we're implementing them or using them and applying them in our education system. I'm old enough that it reminds me of 25 years ago or 30 years ago. If a software company wanted their software adopted, the best thing they could do is give it to universities for free, because then all the students come out knowing that software, right? And so how do we wind up working together on this and making sure that the education becomes shared, because that entire education system winds up going out to the entire economy from that point. So those are a couple of ways that we can wind up doing that. At the same time, that still keeps the competitive process going forward. I think all of us, we wind up improving as a result. So. Thank you. Next, Professor.
Thank you very much. Now, Professor Shirasaka, please. So my question is about how to use the system thinking and system engineering in Japan. I said that it's indispensable, but how can they take root in Japan? What is needed for them to take root? So what is happening in Japan? When we think about systems in Japan and many other countries, we think of IT and software. If that's the case, then people would think that that's not their business. So we have to change our mindset. We have to remove that thinking. So what do we need to do? The top-down approach and bottom-up approach and side-to-side approach, all these have to happen. Top-down approach, simply put, is the government procurement. If the system architect is a required condition for the government procurement, then everyone will try to do so. And it's already happening. For example, super city effort by the Cabinet Office of the Japanese government, the Smart City or Super City initiative requires that architects are included in the project. How about bottom-up approach? So these are happening, so everyone needs to be trained. So they have to train new architects. For example, in Super City or Smart City, it doesn't have to be IT architects. We need the human-centric engineers or architects and system architects, both. So it's not just about technologies. We have to look at the overall picture, and we need the designers or architects who can look at the entire project. So top-down approach, if top-down requirement comes, then the bottom approach will emerge, and then the side-to-side support is needed. So education or training needs to be provided. Otherwise, even if we have top-down and bottom-up approach, things don't move forward. So we need the support from the side. RRI has been making a lot of effort in the last 1 to 2 years, and a system innovation center was established, and they are educating people on the systems thinking. And IP Digital Architecture Design Center is also connecting the government people and the private sector people. And by connecting them, we are trying to train people. And also on the industrial projects, we are having cross-functional projects, and we are trying to also promote regulatory reform. So that's what's happening in the last 1 to 2 years. So it's not simple IT. It is a system concept. We need to first understand that, and we need the top-down approach and bottom-up approach. And systems thinking is not just a traditional system thinking. We need to be aware that there's a system of systems. And with that understanding, the government needs to show that it's necessary, and then the bottom-up approach will have to follow. We need both. in the last 2 years or so, I think that things are progressing. I've been in this area for a long time, but in the last 1 to 2 years, things are moving forward. So, as Professor Kagermann and Professor Johnson said, everything we are talking about is connected. And through the international collaboration, we need to send out the message. And as a result, I believe that the top-down requirement will come and bottom-up effort will follow.
Thank you very much, Professor Shirasaka. Dr. Kagermann talked about autonomy and interoperability, which are quite difficult aspects, but the internationally acceptable standards should be the base for this, and also we have to reflect shared value. I believe that was the point, and I believe that we can continue to talk about these points, but Japanese companies as well, I hope that they can also take part in the activities, and we will continue to study. And also, Professor Johnson talked about how do you make sure that the competitors work together. You have given us the long-term and short-term perspective for the short run. So just following one standard. But to have people have these meetings in public, I believe you pointed out a very important point. And then for the longer run, you talked about the necessity of bringing the same thinking into the education field. And Professor Shirasaka has analyzed the Japanese situation, top down, bottom up, and also support from the side. And all three of you have said that international discussion needs to be deepened. So I won't try to wrap up what you've said even further. Instead, I'd like to move on to the next one. And next is about the expansion of collaboration and international cooperation. I believe all three of you talked about this. So if you can add to what you already said, Professor Johnson talked about the team of rivals and the necessity of collaboration among within the team of rivals. And also in Germany, Professor Kagermann has said that there are areas of collaboration in the industry. Here in Japan, we haven't gone that far yet. But in the United States, as well as in Germany, I believe that things didn't work out from the start. So what was the trigger point in moving team of rivals and collaboration forward? And Professor Shirasaka, you said that things are getting better, but based on your experience and also looking at future measures, if you can make some comments. And in relation to this, already Professor Kagermann and Professor Johnson has talked about this, but the cooperation in international standards, you have talked about the importance of this, especially for smart manufacturing. IEC, ISO is working on this. We see progress, but if we can hear from the three of you of what each country should do and what should happen in the international sphere. Who would like to start? Anybody can start on these questions. Let's say Professor Johnson first.
Okay, thank you. So internationally, I think there's tremendous that we can wind up learning from each other. And in fact, there's not just an opportunity there, there's a necessity to do that. As I said before, not just for economic reasons, but frankly, the sustainability issues that Professor Kagermann spoke about, the future standard of living issues for all of us, by working together, we wind up actually getting further than working individually. And that's the underlying value. There's clearly differences between the US system, the Japan system, and the European system. There have been for 100 years, and there will be 100 years from now, hopefully. That's fine. We all still find a way where we can learn from each other, respect each other, and work together. And I think that's a key part of it. The companies we work with, they all wind up working together. They are on a global basis. And we need to understand and respect that that's in fact the case. And I think we individually wind up finding we have more in common than we have separate from each other. So as underlying values, I think those are important things. Now, in particular things that we can wind up doing, it takes individuals reaching out to make these things happen. I know for myself, I spent part of last year in Europe working on just this issue as well, and have spent time since then trying to figure out how to bring some of these manufacturing initiatives in the United States into partnership with both European and Japanese partners. And I think that's an important thing to wind up happening. Finding those pathways forward, I think is it's just good for everything that we wind up doing. I will make one comment though, that the necessity for doing this always now. Both Professor Kagermann and Professor from Japan both spoke about the exponential growth curves that they wound up having and showing the power of exponential curve. And there's a common perception that somehow exponential curves have an inflection point, and that we are always in that inflection point. And in fact, that's the truth, because if you display, this is just the mathematics of it, if you display an exponential curve on a logarithmic scale, it is a straight line. That is, you are always at that exponential point. You're preparing for what's in the future that's moving much faster than today, and you're at the peak of the past where it's moving the fastest point right now. That is to say, these technologies have never meant more than they have right now, and they will never matter in the future as little as they do right now. So we have an obligation for ourselves to wind up making a firm foundation for it, because the opportunity is only going to continue to grow exponentially going forward. I know that sounds just very, very general activities on that, but this does come down to one-on-one interactions. Finding those individuals who are willing to work across boundaries together is a key part of that.
Thank you very much. So rather than looking at differences, we should be aware that we have more commonalities among countries, and the necessity is always here and now. I think it's a very important advice. How about Professor Kagermann?
Yeah, thank you. I have to say that we have a specific approach in Germany. We believe that we have to get our act together first on a national level, because otherwise you can't speak with one voice. In our case, it's a two-step approach, because first of us, we have to convince then the members of the European Union, and then next, I think usually we go abroad on a global level. That starts usually with standards. I think you are not successful in international standard setting bodies if 3 or 4 German competing organizations are sitting there, or if the German companies that sit there have diverging interests. So that's the reason why we first have these national platforms. In case of Industry 4.0, that was, I would say, to some extent easy, because you have competing organizations sitting there. That's one thing. But on the other side, the public is to some extent outside. It's not a business to consumer market, it's a business to business. So therefore, I would say political considerations are not in this platform. I give you another example which tells you how complex things could be when it comes to systems of systems. I'm sharing since many years our national platform for mobility. And that is by far more difficult because, for example, in my steering board, I have 6 vice ministers sitting there. So we have all stakeholders of the society, from NGOs to businesses, to consumer, to whatever you like. Whatever you can think about is sitting there. We have 240 people, and mobility is, let's say, not just electromobility, is not just, let's say, alternative fuels. This is about the future of our industry. So it's about, what about the workers? What about structural implications? What about shifts in the value chain? And it's endless. And finally, there is climate change. And you can imagine, let's say, how the different opinions of the stakeholders are. So at the end of the day, I think you have a mix of discussion between technical discussions, so defining the standards and international cooperation. But on the other side, more than 50% of my time is just, I would call it, a political discussion amongst different opinion leaders in the society to get at least partially the ideas of the society together in which direction it should go and how our mobility system in 30 years should look like. That comes from people who want no cars any longer, down to the 4 million people who are working in the car industry. So that's my point. And a final point, what is the difficulty on a more international level is definitely antitrust law, because more and more, let's say, experts from large corporations, in particular multinational corporations, start hiding unless it's not only open, like Mark Johnson said, but unless the government is inviting themselves for a discussion, so that the government officials make sure it's not against antitrust laws. And that makes these kind of difficult of discussions more difficult than it was in the past. Thank you.
Well, then finally from myself, if I may. Well, I believe there were two main questions, areas of competition and cooperation, and then about standardization, cooperation and collaboration. Professor Johnson said this, but we are living in an exponential world. Well, then why do we want to divide the collaboration and competition area? So we have this pie which we are trying to share, and in order to do that, we need to have some areas of collaboration, and other areas we need to compete in order to have a more efficient way of sharing. But do we really need that right now? We are now not just looking at one pie. We are sticking things together to create new value. So we don't have to protect a certain area. We should collaborate with the outside world to create new markets, to create new values, and then go out into these new areas. That's faster in expanding your pie. So you should just go out and see where you can expand into. And then all of a sudden, you will see new innovations happening, and that would turn the market upside down. The film camera turned into a digital camera. These big changes are happening, and we now see that the cameras are being replaced by cell phones. So the exponential changes in an era of exponential changes. Static collaboration and competition is no longer feasible economically. we need to think about who we tie up with, who we compete against, and then what will the standards be in when we work? Well, this is a connected world, and Dr. Kagermann often talks about this, but interoperability is going to be important. And the interoperability is not just about data format or communication protocols. It's about, for example, uh, the policies may not be interoperable. For example, security. The format is the same, communication is okay, but the security policy is not compatible, so we can't have these communications. So the policy difference, policy not being interoperable means that sometimes you can't really work together. And then if the governance system is different, once again, we have this hurdle. So interoperability, how we think about this is important, and actually interoperability is really expanding. So what is the standard? And also standard systems of systems. We can no longer determine everything at the design stage, meaning that during operation, new things will happen. And what is the standard for that? For example, in safety, in the past, we had to think about it at the start. And that was used to explain the safety aspects. But in operation, maybe a product will be used in a configuration that was unthinkable in the design stage. What will happen then? It means that we need to have a standard for operation. In addition to the standards for design, we need to create that, or else we will not be able to use products safely and securely. So interoperability and this operational part, we have to focus on that when we think about standardization. That's all from myself. Thank you.
Thank you very much. Dr. Kagermann, I didn't comment on your response, but in Europe, you first need to convince the stakeholders, and then you need to convince stakeholders globally. So you need to take a two-step approach. And Industry 4.0, first, the overall discussion was carried out as you formulated standards. So I think that you need to approach the society as a whole. And you also touched upon the antitrust law. And Dr. Shirasaka talked about the competition and the collaboration, but you said that this concept is old-fashioned. So rather than taking the share of the pie, you need to think about how to collaborate with others. And from the designing phase, you have to think about the operation too. And Professor Johnson has a question to Dr. Shirasaka. So Professor Johnson, can you ask the question?
Yeah, not so much of a question, but when you mentioned that, it's about the purpose of all of this is how do we grow the pie faster than we separate the pie up? And that's a very, very good analogy. I think one of the motivations behind all of Industry 4.0 and all robot revolution and smart manufacturing is how do we wind up growing our economies faster for the people that work in those economies, right? And that is labor productivity. And this reminds me of a famous quote by an MIT professor that said, I see computers everywhere except in the labor productivity numbers. And I think that's actually a shared problem that all three of our countries can wind up working on, because the labor productivity in all three has taken a sharp decline over the growth rate. They're still growing, but the rate of growth has tapered off over the last 10 years, basically since 2010, even though we're introducing all these new technologies. So who winds up benefiting is not just in the companies, but in the people that wind up doing it. I think that's an area we all have opportunity to work together, because for this to grow sustainably, we not only have to grow our businesses, but make it so our societies wind up getting benefit from that overall too. I think that's a really important issue of what you all are working on.
Thank you very much, Professor Johnson. And yes, our time is running out, so I'd like to move on to look at paradigm shift. What kind of paradigm shift do you think is important? If you can explain. And then after that, we have some questions from the audience. We might be able to pick some up. So on paradigm shift, so we have shown you 11 possible paradigm shifts, but what other paradigm shifts do you think will have a big impact?
Who?
Because nobody was asked to start, I will do this. Thank you. I personally believe.
Okay. Since you have the microphone, Professor Kagermann, please.
I would like to pick two. There's a big list, and I have mentioned a few of them in my talk where I believe a paradigm shift is not necessary. But let me pick two of those. The first one was addressed by Professor Shirasaka. I think that is system thinking and system design. That's not, as we all know, a new topic. It's there. If I look to my academy, I think most of our professors push for it because it's obvious that that has to be done. But on the other side, it requires, first of all, more experts talking to each other, which I find sometimes is very difficult. If you find that people, let's say from, let's say the engineering have to talk to people from the Department of Sociology or from philosophy, which sometimes happens if it comes to value-based design, people just can't understand each other. So it starts in science, and you can understand how difficult it gets if you open up to all stakeholders, as I mentioned it earlier. So from that point of view, it requires a kind of trust into what experts are saying. And the issue I'm seeing is that in the society, there are trends that people don't trust any longer the experts and the politicians. That makes it difficult because the future is more complex and unpredictable. Therefore, I think you need more or less trustworthy experts. You cannot be an expert in everything. That's the reason why I believe system is key. In particular, give a second example. You have also to look cross industry. In Germany, when let's say when I look for what is the future of mobility, that just can't be done without looking to the future of the energy system. And that is under transformation as well. And it's not easy to find people who work in both areas. It's even worse. The ministers are responsible for separate areas and they have the separate agenda. So it's even coming to the political level. So that's enough for that. My second point is the education system. That concerns me most because I think that's the future of all of us. It's much more important than anything else. And what I see is that I think the old way of educating is just old-fashioned. I just believe we don't have the time in these fast-moving times to go for, let's say, 6 years education, very dedicated on something, then believing we can use this our entire life. That's gone. So therefore, I think the entire way how our schools and our universities prepare young people to enter business has to be different. And my second point is that then, if it comes to lifelong learning, it's more responsibility of the businesses to take care of their employees and not only look that these employees are valuable for themselves, but for the society as a whole. So this is kind of, for me, a next social contract, which is not so much today in the minds of businesses, but needs to be there. And the final point is that the public education system has to adapt because we need the public education system so that as people enter the business life, they don't get a shock that everything is different, that they have been educated. educated before. These are the two topics from my point. Thank you.
Thank you very much. System thinking is needed. And also you need to go beyond the industry and education system and also lifelong education. You talked about the importance of all these things. How about you, Dr. Johnson?
Thank you. Looking forward, I think two things that are very, very important. In the semantic view, the systems design, the vertical axis was looking at the how and the why and what we're working on. I think adding within that semantics around bringing the human into all of these systems and consideration of the human needs, for lack of a better term. A semantic structure that looks almost like a Maslow's hierarchy of human needs, where the very basic level is how do things work and how do things safe? And then how do things collaborate? And those are all the very cutting edge ideas around artificial intelligence, for instance, right now. But we have much higher levels we can look at, which is the issues of how do we wind up creating, not only working in communities together, but creating and ultimately personalizing all of these things. And I think that's important, not just for the consumer end, but in the world of making, in the world of designing, in the world of business overall, of interconnecting across those things. So I think the important issue that we move forward is not only having the Industry 4.0 concepts, but moving beyond that to the world of bringing the consideration of human needs overall into these. And I think all these programs are working down that direction. That will only get more and more important. The flip side of consideration of the human need then is considering the constraints, whether it's energy resources, whether it's material resources, whether it's considering what do we do with all of our waste, the terrible issues that are happening with oceans and plastic and all those sort of things that are happening, and understanding the technologies to pull those together. As Professor Kagermann says, it's very hard to just find people that can work at the convergence between those two things in the field of experts, let alone how do we wind up developing the solutions against the other constraint, which is the time constraint. We're going to have to do this all faster and faster and faster. Now, this is no different than every other generation before us. I think we're in a good place to wind up succeeding at this. And, let's keep working together.
Thank you very much. Professor Shirasaka, please. Well, among the 11, I chose 3. One is the value creation and competitive advantage, and structure, and then education. The first one, value. I've already talked about this, but I think the way of thinking about value is changing. Somebody is no longer satisfied with just buying a product. It's like a journey. You have to provide value along that journey. And it's not just the individual. We also have to think about sustainability. Both professors have said on a global scale, we have to look at value. For example, SDGs. Everybody thought that the SDGs were important. So the way we look at value is changing. It's not just about somebody gaining something. And then that would impact structure. So you gain value here, you gain value along the way in the journey. And then in order to provide a product, you need to have a supply chain to do that. And then in the process of the supply chain, a lot of things will get involved, and sustainability has to work here as well. So everything is connected in this structure, and value has changed it. So we have to use everything in that structure to provide value. And that's the big difference. Things were thought about individually, but now we have to integrate everything in our thinking. Well, then who is going to do that? That reflects to education. And as Professor Kagermann and Professor Johnson said, not many people understand different fields. Nobody would understand everything. So then how do we have this holistic view? How do we nurture people who have holistic views? Germany, United States, Japan, I think Japan lags most behind in the world of education, and that's because people are not re-educated after they experience the society. In Japan, once you start working, you don't go back to school to learn, basically. Right now, we're trying to change that, but once you join the workforce, they are suddenly shocked that they see that what they learned in school is not really useful. So it means that they have to go back to school to relearn the necessary skills. NBA was the only thing that provided such education. There are nothing else in Japan, and I believe that's going to be tough going forward. Based on experience, learning new things is very important, especially from the systems perspective. uh, if you don't have experience, just talking about the theory is not going to be enough. Uh, the person has to have experience in order to have a systems perspective or a holistic perspective. So, this education system in Japan has to be changed. The government is trying to do something, but we have to move faster, or else it's going to be tough going forward. So, those are the 3 points that needs paradigm shift.
Thank you very much. So we don't have much time left, but we still have two big questions. The first question is from a member of the audience. System architect, nurturing system architects. I think that Dr. Shirasaka already touched upon that. So Dr. Kagermann and Professor Johnson, we have one question to you, and then I will ask all of you on the role of RRI and expectation toward Japan in Industry 4.0 and Society 5.0 effort. And we will wrap up. So the question to Dr. Kagermann from the floor. Composable business. Can you share with us any specific example of composable business, and what are the actions that you can take to promote that? And the next question is to Dr. Johnson. It's a very simple question. In the United States, there will be a presidential election in November. Depending on the result of the election, will the manufacturing policy be changed? So, Dr. Kagermann, can you start?
Yeah, thank you. The concept of composable business processes, I think, is well known. I touched on it. What do I mean with composable business? I give you two examples. One is the more people focus on sustainability, the more I have heard from many CEOs that they look into their business portfolio if it fits to the needs of sustainability in the long run. In particular, if they look to their shareholders, their employees, their customers, many of them are demanding that. What does this mean? Shifting demand and shifting your, I would say, business activities quickly. That is one piece. Mostly, the issue why they can't do it is simply IT, because the IT architecture and the IT systems are neither done in a way that you can easily push things out, nor can you integrate things easily. That's the one piece. The second is with upcoming software as a service, you can do those things. I give you two examples. You can start building your own smart factory. That takes time. But you also can go to some of the startups we have, which are, let's say, offering smart factory as a service, which means you just, let's say, include the ability to do, let's say, the lot size of one in a more customized way in just contracting manufacturing to somebody else. That's one thing. Another one I have seen in banking, I'm in the board of a, I would say, medium-sized company which offers core banking as a service. And interesting enough, this is good for new kids in a block of emerging countries where new institutions go up and they don't have just the time to build those stuff, and they just get in and get up to speed in a few months. And on the other side, if you look to incumbents and they want to address new areas, new business areas, they just have the support underneath. So therefore, you would call this a kind of composable business. Why? Because the IT architecture behind is, let's say, based on microservices, which means you can just tip into another cloud where somebody offers this microservices and run it in your environment. So this is the architecture of the future and allows you, let's say, just to open up a new business because the IT support is there and you don't have to do it yourself. That's it. In a nutshell.
Thank you. So thank you for your question on will there be a presidential election in 3 weeks from the United States, or an election, and what will that mean for manufacturing policy? And the answer is yes, there's an election. I understand that both in the United States and internationally, one might think there is only a presidential election because of all the Twitter noise or whatever out there of information. But in fact, there are 438 elections for House of Representatives. There are something like 33 Senate elections that are going on in the United States. There are 100 senators, and 1/3 of them are elected every 2 years for a 6-year period. And there are something like 20 governors in the United States in each of one of those states. The other 30 or so are elected in the off year, it's called, 2 years later, but they go for 4-year cycles. So the answer is yes, there's going to be an election. Do I think that there's going to be a change in manufacturing policy is the question on that. And I think this is one of the actual strengths of the sort of, I don't want to call it chaos, I would say the randomness of the team of rivals approach is it doesn't change very quickly. And that's the reality. So if you look at all of the, and don't tell the presidential candidates this, they probably have more in common than they have apart on manufacturing policy, because everyone needs manufacturing, everyone needs jobs. And I can say for a fact that the published Department of Energy policy of the current administration on manufacturing and energy is the identical published policy of the previous administration. Why do I know that? Because I actually wrote that policy, and you can look that up as their multi-year program plan. So, you know, that, and the trick is, you know, politics is there's a lot of showmanship that goes into it, right? But then there's governance. And I think that this is the good news, is that in every one of our governments, there are very committed people that are public civil servants, that are not the politicians, that have a lot of expertise, that work hard to make sure the right thing gets done in the long run. And so that's what I think is going to wind up happening. Are there individual policies, and are there is there a lot of noise? Yes, on all of these things. What we hope is that there's a reasonable expectation for business that they can understand what the future might be. Because as long as they don't have chaos, then they can know how to invest. And I think that's what we need more than anything else, is stability in that expectation, that understanding of what the future can wind up being, because we can wind up then working together on those things. I'm not going to predict who's going to actually win, though.
Thank
you for that. Now, last question to all the panelists. Society 5.0 and Industry 4.0. What do you expect from Japan, and what are the roles expected from the global community? If you can respond to this question in 1 minute, I would appreciate it, and then we can wrap up the session. So, Dr. Kagermann, can you start?
Thank you. I'm very much concerned about the trend I see in the direction of self-sufficiency and technological decoupling, as we see it, for example, between US and China. I don't think this is the right way to go. And therefore, I stress so much the way of self-determination, which is completely different. I also believe it's dangerous, these trend of self-sufficiency for expert countries like Japan and Germany. So therefore, I would hope that Japan would use its economic power to open up more and influence the global community. And I believe that the Robot Revolution Initiative, in particular in the area of manufacturing, is an established, I would say, a reliable and capable organization that could support this.
Yes, thank you. And I completely concur with you that having an ability to wind up working together across these international boundaries, we essentially have to figure out how to do that well and do that securely. That's consistent with our values. Relative to Robot Revolution Initiative, as I understand it, one of the things I think is a wonderful motivation for why this is such a necessity is actually looking at things like demographics and how we have to get everyone that works in our factories to have robotics and have Industry 4.0 to make them more productive, to make their lives better as they're making the things we wind up needing. But at the same time, it's clearly Japan communicating its values, that it needs to have everyone of working age more productive so it can support the societal programs that result from that. By having that gross domestic product growth, then you're able to wind up taking care of your people overall. And I think that's a tremendous value of what you are doing, and being able to communicate that says really a lot about what Japan really believes in, and that is you should be commended on that.
Thank you very much. Professor Shirasaka? Yes. I'm Japanese, but Japan is the first country to be the super aged country, so the working population will decline further and further. And Dr. Kagermann and Dr. Johnson said that efficiency is a very important issue for Japan now. It's an urgent issue. But at the same time, as the manufacturing major country, the industry has driven Japanese economy. And the world has seen Japan as a country that has produced high quality goods, and it's a highly hygienic country and clean country. So such strength of Japan needs to be utilized in tackling the issues related to aging society. And Society 5.0 and Industry 4.0 and other new projects or new economic structures. In order to create these structures, we have to make contributions. And especially in manufacturing realm, RRI has all the members who are the companies that are supporting manufacturing industry in Japan. So new values and new ideas will have to be formulated in RRI, and then the message needs to be sent to the global community. The training, education, the popularization, that needs to take place in Japan. And RRI is the organization that can really drive that effort. And I would very much like to make effort myself, make contribution myself. And I think that a lot of the members of the audience are from the manufacturing industry. I hope that they will be involved and engaged. We welcome their engagement because society will be changing significantly. RRI should be at the center of Japan as a manufacturing major country, which will be driving the entire global community to make transformation and changes. We need collaboration. Thank you very much.
Well, thank you very much. We have overrun our time, therefore we'd like to wrap up. But today we had 3 people representing Japan, United States, and Germany to look at the manufacturing business and paradigm shift. We have heard a lot from different perspectives. And also the COVID-19, which is a new challenge for us. We have learned about how countries are trying to deal with this, and also the direction of more speedy response. I will not try to summarize what I've heard, but team of rivals may be what a word that will represent the system thinking as well as expanding private-public collaboration, and also, as we've heard in the last session, global collaboration to work on common challenges. Well, the MC has not been able to keep time. I'm very sorry for the poor management, but thank you very much for your active participation, and thank you to the audience as well. And I'd like to ask for a big round of applause to the three speakers. Thank you very much. And with that, I would like to end today's session. Thank you very much.
ありがとう。